going to give this example of how to compute this integral. Again, this is going to be, well, let's just think through this from the beginning. If I draw the curve, I like to figure out what the curve looks like first. The curve looks like this, and it's assumed to be oriented positively. It's the unit circle. Now, the first question I have to ask myself is the integrand holomorphic inside the unit circle? And the answer is no. The numerator is, but the denominator is not, because the 0 is a bad point. If I plug in 0, the integrand is undefined, which means it's certainly not holomorphic there. So if this is the case where the integrand is not holomorphic, but the numerator is, and the denominator just looks like something of the form z minus w to the n, here we have z minus 0 squared, for instance, then you're going to use either Cauchy's integral formula or a modification of it. You get to use Cauchy's integral formula if you just have z minus w to the 1. You have to use a modification of it if you have z minus w squared, cubed, etc., etc. So we're going to use a modified version. And I explained this in a previous screencast. And so what it is that the formula is, as long as you have, a nice enough curve, if you have f of z over z minus w squared dz, where this is in the interior of gamma, right? If it's not in the interior of gamma, all of a sudden this is holomorphic, because all the bad points lie outside of gamma, and so you can use Cauchy's theorem, just contract this and get to a point, and they get the integral is equal to 0 if you have a circle. So I'm going to use this formula. This formula just says, well, this is equal to 2 pi I times f prime evaluated at w, the bad point. So that's what we're going to do. This is what Cauchy's integral formula says. Let's make a really long equal sign. 2 pi I times f prime of w. Well, what's w? W is my bad point. It's the point that's keeping the function from being holomorphic. And the catch is there can only be one. If you have multiple ones, you can do some tricks. I'll do an example of that in just a second. As far as I'm concerned, you might be watching this days apart. So 0 is the only bad point here, so this formula works out well. So times f prime of w, because 0 is the one that makes the denominator equal to 0 if you plug it in. And f prime, right? F prime, this is just the numerator. So I need to take the derivative of the numerator and evaluate it at 0. Well, the derivative of sine is cosine, and I plug in 0. Oh, I know what that is. I've known that since high school. Times 1 equals 2 pi I. And this is the answer. And so we applied the formula. This is the modified Cauchy integral formula. That's all there is to it.